This lesson we're going to talk about exponential growth and decay applications, the application problems of those concepts. The exponential function is a function that grows really fast, multiply by the same amount every single time, or dies very fast for the same reason. And here's our formulas. A is our initial amount, and B is our growth rate. If B is bigger than 1, it's a growth. B is less than 1, it's a decay. Well, between 0 and 1. That's all this up here. Initial amount, constant ratio, growth factor, decay. We haven't talked about this yet. The formula for growth decay factor. We haven't talked about these formulas yet. They're the same formula, just it breaks down your growth rate by the amount you're actually increasing or decreasing, known as the rate of change. Here, 1 is just 1 plus R. R is the growth or decay rate. So this is the rate of change. How much are you growing by? How much you're decaying by? That's what the R is about. If it's at 1, it's stable. You're not growing or decaying. But once we add to it, then it's growth or decay rate. As we talked about before, E is a special number. E is used in exponential problems that involve continuous growth or decay. E is 2.171828. And it keeps on going. It's a number you find all across nature, but we use it all the time in exponential problems. A lot of times in business and finance, you'll see E a lot. E is kind of like pi. It's a special number we use all the time. So 2.718 blah, 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 we'll use E. Let's bring out a calculator. Here's my scientific calculator, all we need. How do I figure out what E is? Let's try 1, then E to the X. There we go. E to the first, hit enter. And like I said, it keeps on going. It's not in the end. It doesn't ever repeat. It's like pi. 2.718288183. 4 decimal places, sorry. 1, 2, 3, 4. We have to round up. 2.7183. Helps if you read the instructions. There we go. 4 decimal places. Okay. E to the third. So now I'm going to do that one. All clear. We'll do 3EX. That's E cubed. We get 20.0855. The next one would be 3. I don't round at all. I round down basically. So there we go. E to 3 halves. I usually use an actual calculator instead of this. There we go. I get 4.4816. I have to round that up and make it 7. The one right behind 6 is an 8. We round up. That's how you use E. So again, E is just a special number, kind of like pi. We use it a lot in exponential problems. Let's talk about interest formulas. I'm actually going to start with the compound interest formula. This is, if you put money in a bank that gives you interest, the bank pays you for keeping their money. And this is how they figure out the interest. So what they're going to do is they're going to compound it, which means they're going to figure out how much money they should add you, either annually, once a year, semi-annually, a couple times a year, quarterly. In that case, that's 4 times a year. Let me put these down. Annually is 1, semi-annually is 2, monthly every month. It means every month they'll figure out the interest they have to pay you and they'll add it to your account. That's what compound interest is. Put money in a bank, they pay you for keeping that money. That's known as interest. And the way they figure out the interest is by doing a compound interest formula, where they compound interest either once a year, twice a year, quarterly, 4 times a year, monthly, 12 times. They could do daily. They could do every 3 months. They could do whatever. Okay, that's the idea. Now let's talk about what all these letters mean. I'll start with P. P stands for principal. That's your initial amount, your deposit, also known as what you put into it. R is the rate. Now it has to be in decimal form. If they give you 2%, you have to move it over to a decimal. We'll do that's what R is. N is the number of times they figure out the interest and compound it. Annually is 1, semi-annually is 2. T is years, time in years. Make sure you're doing it in years. So yeah, there's NT right there. And A is the amount in your account after so many years, also known as annuity. A is how much is in your account after so many years. P is the principal or the initial amount, the deposit. R is the rate that they're giving you. N is the number of times they're going to compound your interest. They're going to figure out your interest and add it to your account. And then T is the number of years. Once you have all that down, all we got to do is type it into our formula. This first one, 7,500 deposits. That's our P. Into an account that compounds monthly. Remember, monthly is they're going to do it once a month. So there's 12 months in a year at a rate of 4%. We got to make that a decimal. So the way you make that decimal, if it's 4%, if you don't see the decimal, it's behind the number, you have to move it over 2 spots. So 0.04, like that. If you don't see the decimal, it's behind the number, and you have to move it left 2. That's how you make it a decimal from a percent. Find the amount of money in the account after 5 years. That's my T. So we're going to put the formula. A equals P, which is 7,500, parentheses 1 times R, which is 0.04, over N, which is 5 years. Oops, sorry. Compounding to 12 every month, with 12 to the power of NP. That is going to be 12 times 5 years. Now, with the scientific calculus, it's a little more difficult. Let's see if we just type it in the way we see it. I don't have this spot to put it. Let me clear this. So I'm going to put 7500 parentheses 1 plus R 0.04 divided by my N, which is 12. Close parentheses. Take it to the power. So the power button is, I don't want any of those, this one, because I want to make my own power. And then I need a parenthesis. And I want to do 12 times 5, also known as 60. Hit enter. That should be all good. And we get, after 5 years, we now have 9,157 and 47 cents. Keep in mind, it is money. You should only go to the nearest 100. Now, again, that's not the money I made. That's how much money you have in your account after 5 years. Okay, we have that down. We do the next one real quick. Our formula is this. So in this case, I'll type it in, but we won't put it into the calculator. Let's figure out everything. This is my P, my deposit, my principal. Quarterly means we're gonna do it every 3 months, 4 times a month, 4 quarters in a dollar. My rate, that's the hardest thing for most people. 2.5, I gotta make that a decimal, not a percent. There's our decimal, we have to move it over left 2 spots. 0.025 is my R. And we're gonna do this after 3 years. T equals 3. Let's write it up. A equals 5,000, 1 plus R, which is 0.025, over N, which is going to be quarterly, so 4, to the power of 4 times years 3. And again, we'll type into our calculator, get an answer. That's a compound interest formula. Now, that's if they do it annually, semi-annually, all that stuff. But there's another version of this, which is called compounded continuously. So they just never stop figuring out the interest and giving it to you. This is generally better, but it really only matters if you have a large amount of money. But what we got it's a much similar formula. It's A equals PERT, also known as APERT. So in this case, we'll talk about each thing means. A is the amount of money in our account, just like last time. P is the principal, just like last time at our deposit. R is the interest rate. Again, it has to be in decimals. And T is the year. What's the only difference? E, that special number E, we're going to type into it. But that's it. If it's compounded continuously, the bank just keeps compounding interest for you infinitely many times. So this is generally the preferred method. Anyways, type it in. So what if I have $1,200 at an annual interest rate of 5% for 5 years? Remember, I got to make this a decimal. 5%, if you don't see the dot, it's right behind it. You move it over 2 spots, 0.05. We use the formula A equals P, which is 1,200, times E to the R, 0.05, times T, 5. So that's the formula. Let me bring up my calculator. We're going to do 1,200. Let's all clear this. 1,200 times E. Mine's a little funky. I have to type that thing first. I'll put parentheses. I put the power first with this calculator, and then I'm going to do the E. There we go. That's the way it works for this calculator. And I get 1,540.83. It's money. After 5 years, we have about 1,500 in our account. We made a little bit more than $300 after 5 years. Same thing here. If I was going to do this one, right? This is our formula. I need my principal, which is 1,300. I need my rate, which is this guy. We got to make it a decimal, so move it over 2 spots, 0.043. And my T is years. A would be 1,300. E to the 0.043 times 3 years. Again, just before you put that in your calculator and get an answer, I'll let it be. So those are compound interest formulas. But we could also do growth decay problems. So with the growth decay problem, we're generally going to use this formula. Where again, R is our growth or decay rate of change. That's how much are things either growing or decaying by. Other than that, it's a general formula. Let's do an example right here. So I'm going to write down the formula first. Y equals A1 plus R to the T. Again, R is our growth rate, T is time, A is our initial amount, just like before. So A is initial, R is the rate of change, and T is time. Let's look at this first problem here. In 2018, the population of a small town was 12,500. If the annual rate of decrease is about 5.8%, what is the population in 10 years? Okay, a couple things here. That's my initial amount. That's my A in this case. Our annual rate decrease, this is our R, and we'll talk about that. Let's move on for a second. What will be the population in 10 years? This is my T. T is 10. Just like before, I cannot put 5.8 in there. I have to make it a decimal. 5.8, move it over 2 spots, 0.058 is my R. Very important. That's my R, not my B. It's not all of this. It's just the R part. That's just how much we're increasing or decreasing. And in this case, we are decreasing. So it's actually going to be 1 minus R we're going to use. For decreasing, we should be a decay. It should be less than 1. So we're going to subtract the 1 from there. Let's put the formula down. Y equals my initial, 12,500. 1 minus my rate, 0.058, all to the T, which is 10 years. And that we can type into our calculator. 12,500, parentheses, 1 minus 0.058, close parentheses. And again, I want to do a power of 10. So I'll put this XY power and 10. Hit enter, and I get 6,877. And it's people, you probably round to the nearest person in that decimal there. Think about that many people. So that's how much it grows. Or actually decreases. After 10 years, they've almost had lost half their population. Let's do another one to make sure we got this. Same formula. Y equals A1 plus R to the T. A certain type of bacteria triples every hour. If there are 20 bacteria to begin with, how many will there be after 8 hours? So let's figure out what everything is. To begin with, that's your A. After 8 hours, that's your time. Now here's the rub. It triples every hour. They didn't give us a rate of increase or decrease. It triples every hour. This is actually our B. Our B equals 3. It's not this guy anymore. It's actually this formula. We use this formula if they tell us to increase a rate of increase or a decrease. We don't have that. We just have, it triples every hour. That's every hour multiplied by 3. That's our B. Formula's going to be Y equals 23 to the 8 hours. And now we just have it to our calculator. application problem. Use a lot of calculators. 20 times 3. Again, any power 1, use that one to the 8th. And we get 131,220. That's a lot of bacteria in 20 hours. They grow. Anyway, that's the lesson.